In this video, we will be doing two proofs, one in yellow, one in red, regarding addition of segments. So each one has one theorem, and you'll see how they work together. Going to the yellow one first, given AB is congruent to AC, BD is congruent to CE, prove that AD is congruent to AE. AB is congruent to AC, given AB is congruent to AC, BD is congruent to CE, given BD is congruent to CE. Then AD is congruent to AE. Reason, if congruent segments are added to congruent segments, then the sums are congruent. Quick number thing to make it more salient. Let's say that's 2 and that's 5, and then that's 2 and that's 5. Then the whole thing here would be 7, and the whole thing here would be 7. Specific numbers make it easier to see, but make sure you can do this just as a general thing. Next in red, given FG is congruent to HI, FG is congruent to HI, prove FH is congruent to GI. So now, two-column proof, FG is congruent to HI, given, so FG is congruent to HI. Now we're going to prove that FH there is congruent to GI here. And we'll give a little circle on those two. Now the reason for this, if FG is congruent to HI, and we add GH to both, GH is congruent to itself, then FH and HI must be congruent. So again, let's say that FG is 5 and HI is 5, and then GH is 2. Well then, 2 plus 5 is 7, 2 plus 5 is 7. So make sure you can see with the numbers, but make sure you can do it without the numbers as well. So FG is congruent to HI, given these two here. FH is congruent to GI. FH is congruent to GI because if the same segment is added to two congruent segments, then the sums are congruent. Make sure you can see the difference. In the yellow, if congruent segments are added to congruent segments, then the sums are congruent. Those two and those two. In the red, if the same segment is added to congruent segments, then the sums are congruent. We add the same segment to each of these congruent segments and get congruent segments. Run through it a few times and you should be good.